now, you know that y equals sine x. You know what it looks like. Do you know what it looks like? What does it look like, Ms. Tippins?
Oh, it's going through 0, 0.
Uh-huh.
And then it's, yeah, like that.
All right. Now, Ms. Tippins, you have a vast mathematical knowledge, and you did test your ability to understand the family of functions. Are you ready?
Yeah.
Here we go. What would y equals 2 sine x look like?
Does it go up to 2 on the y?
Exactly. So it's going to go from here up to 2. Then 2 times 0 is still 0, right?
Yeah.
And then negative 2. And back here. So we're going to describe that kind of family of function change as not a stretch. We're talking about waves. We're going to talk about it in terms of what a wave actually looks like, and so we're going to call this the amplitude of the wave. So when you do this, you get an amplitude of the wave. So my amplitude of this wave is 2. Now, should I address the number one problem you're going to have? Ms. Tippins?
Yeah.
All right. Say you're going to the beach in Southern California, and you hear the waves are 4 feet and breaking. What does that mean?
That they like get to 4 feet like tall and then they break.
Yeah, so they're 4 feet up in the air, right? That's what you think?
Yeah.
Surprise! Here's what really happens. The amplitude, which is only this distance here, is 4. Which means when you're out there swimming, how high is the wave?
8.
8 feet tall. So amplitude, the important part of this is the amplitude is only half of the top to the bottom, okay? Try to remember that because people forget that all the time. Are you with me still? You doing good?
Yeah.
Ready for the hard part?
Sure.
All right, let's do the hard part. What happens when I do this? And it's a completely unfair question, so just relax a moment before I do this. Oh, let's not start with the advanced course. 2x. What happens when I do that to you?
Does it make it like wider?
Sort of. It affects the width. It does. Now, first of all, let's talk about y. When I do y equals sine x, let's make an xy chart. Ready? If I put in a 0, I should get a 0, correct?
Yeah.
When I put in a pi over 2, what I would get is a 1. Agreed?
Yes.
When I put in a pi, what would I get?
0.
0. 3 pi over 2?
-1.
And then 2 pi.
0.
0. Okay, so far so good. We agree on everything so far. Now let's look at this equation over here. Yes?
Can you reset the camera? I can't see.
Okay, I'm going to re-share the board. Whoop. Here we go. Okay. All right. So when I do this, you should be able to see it right about now. Are we good?
Yes, thank you.
Cool. Okay, so Ms. Tippins, when I plug in a 0 in this equation, what happens?
Multiplies x by 2?
Right, so you're going to 2 times 0, which is what?
0.
0. And so we're still going to get 0, right?
Yes.
Sine of 0 we know. What happens when I put in a pi over 2? Pi over 2 times 2 would be what?
2 pi over 2.
Which is?
Pi.
Pi. What side of pi?
0.
0. So I get a different answer. No, I don't. Yes, I do. Got a different answer, didn't I? What happens when I put pi over 4 in there?
It'll be pi over 2.
Which is?
1.
1. Then 3 pi over 2 would therefore likely end up giving us negative 1. And pi becomes 2 pi. We're back to the beginning. 0. So what happened to my graph? This graph over here, we know it. It looks like this. We go side up, 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 2 pi. What happened to this graph?
It'll, I don't like know how to say it, but it'll get like skinnier.
Right, so we'll have 0, 0. We're at pi over 2, we're back at 0. And at pi, we're at 0. In between, we go up, down, down, up. Agreed?
Yeah.
So you're correct. It kind of skishes the graph. Now, it skishes the graph. We have a technical term for skishing, which is how long until it repeats. We call that a period. A period. And we're going to use the letter T to describe it. My period is how long until it gets back to where it starts. Are you with me, Mr. Donahue? Because again, that's going to be helpful when we're graphing these. Now that said, how do I find my period? What did it do? This 2 cut my 2 pi in half, did it not? Ms. Tippins, you agree with that too?
Oh, yeah.
Okay. So 2 pi, what we did is we divided it, didn't we?
Yes.
So we're going to write 2 pi over, and I'm going to, do I want to use a K or an omega? I switched to omega already. Oh, that's coolish. All right. Where omega is going to be the number in front of the x. What is the period? How long until it repeats? Call the period. This is the number in front of our variable. I'm going to run out of space. In front of variable. You did that really well, Ms. Tippett. Probably too well. Is everybody caught up? Zion, you caught up? All right. I'm going to turn the page. I forgot to say one thing. Ms. Tippett, since you're a pro, what if I put a minus out in front?
Does it like flip it?
Flips
on
it.
The x-axis?
Absolutely flips it across the x-axis. Same rule as always. All right, with that in mind, everybody should try number 1 on the back. Try number 1 on the back. 1, okay. So like 1 here, 2 here, negative 1, negative 2 here. Let's do pi and 2 pi. Pi. Oh crud, I did too small. 2 pi? Yes. Sorry, it's off my graph. You guys, I should fix it. I should fix it. I should go to trouble fixing it. Be a good teacher, not one of those lazy ones. How's this? Better? All right. Negative 2 pi. All right. All right, Mr. Sussman. The equation at hand is y equals negative 2 sine theta. It's number 1 on the back of 5, 9. What do you got for me?
You start at 0.
You start at 0. Now, I'm going to start it by drawing the parent graph. What is a parent graph? Parent graph is y equals sine theta. I know how to graph that, right?
Yeah,
so I'm going to simply go like this. I'm going to go. So that's what the graph should normally look like, correct?
Yeah.
All right. Now, what am I going to do? Start from the left to the right. What does this thing tell me to do?
So it's going to tell you to flip it.
So flip. So I'm going to go like this. Oops. Excellent.
And then you're compressing it by 2.
We're going to
So
say,
it goes taller.
we're going to say the amplitude is 2.
Oh yeah.
Okay, that's what we're going to say. So instead of going to 1, it's going to go to 2. Instead of going to 1, it's going to go to 2. And so I'm going to draw it like this. Agreed?
Yeah.
Now you just keep going on the back side. One, 2, right here. That's the spot. Okay. Where's 4 pi? I messed that up. Oh, wait, 4 pi would be 1, 2, 3, 4. There it is. I got it. Okay. That's how you do that one. Is that okay, everybody? Donnie, you good?
Yeah.
All right. Go ahead and try the next one, the advanced course. Or the more advanced course.
Just gonna start at 1.
It's a normal cosine curve, right? It's gonna be a little tricky because this graph is kind of weird, but I'm gonna go like that would, oh, that's why I just stopped there. I messed this up. It's gonna be trickier than I thought. Let's fix that. 3 pi over 2, and this would be 1, 2, 3, 3 pi. So normally this would be that much over, so you'd go like this. Cosine would normally look like this. Agreed?
Yeah.
That's my parent graph. So far, so good.
Yeah.
All right. Check. What I'm going to do, because I got a 4.
The amplitude is gonna be 4.
Amplitude is 4. So that means I'm going to go up 4. 1, 2, 3, 4. Bottom is going to be at 4. 1, 2, 3, 4. Back up to 4. The zeros remain the same. Good so far? All right. Now the parts that you were dreading. Period. Period equals 2 pi over omega. That's going to be 2 pi over what?
3.
Over what? 3?
Because this is the number next to the theta.
Right. What is the number next to the theta?
Oh, 1/3.
1/3 is next to theta. Pausing there because you're not the one that made that mistake. You could rewrite this as y equals 4 cosine 1/3 times theta, couldn't you? So it's a 1/3 that's next to the theta.
What happened to the 2 pi?
Whatever the 2 pi, 2 pi is still on top.
Oh yeah.
I just want to point out why it's 1/3, because that sometimes that by itself is like, what is he doing? He's making stuff up. So if you got a fraction, it does you a favor to pull it out in front, like you were. One of you two was trying to do with the earlier problem. Now, how do I have a 2 pi fraction bar 1/3? What do I do to get that fixed?
Plus 5 pi reciprocal. So
Flip and multiply, yeah. Flip and multiply. So I got period equals 2 pi times 3 over 1, which is 6 pi.
okay. So okay.
All right?
So yeah.
I'll pause there. Let's make sure everybody's with us. Anybody not with us on the 6 pi?
What's the number for the 6 pi?
3 over 1.
No. The after the that
2
one.
pi?
Oh, it's 2.
Right, because we got 2 pi over 1/3, so we're going to flip and multiply.
Why is it 2 pi over 1/3?
Aha! Because we're supposed to put the number that's in front of the theta right here, aren't we?
Yeah.
What we notice is that we got theta over 3, we get a little confused. But if I rewrite that as 1/3 theta, I know what's in front of the theta. It's 1/3.
And the 2 pi is there because it.
2 pi is always there.
Okay.
Period's always 2 pi. I shouldn't say that. For sine and cosine, it's always there.
Okay.
Tangent, I'm going to take that back. For reasons I absolutely hate. I think, by the way, period, they should be, 1451.